Engineering 305, Chapter 5, Problem 3. The steel. It gives us a Young's modulus of 29,000 KSI, 29 MSI. Pipe column shown in Figure 5.3 has an outside diameter of 6 inch and a thickness of 0.6 inches and a length of 24 inches. The axial load imposed on the column by the timber beam is 30,000 pounds. That load, 30 kip. Almost 10 minivans. Find out the normal stress in the column. So let's start doing it. Find sigma normal. Well, that's F over A. Well, I got my force and I can calculate area. Okay. The change in length of the column. Well, I'm jumping ahead, but if you go to the study guide, right, you're going to get delta is equal to PL over AE. And if you've been in class, you know that one. And lastly, that's the change in length. The average axial normal strain. Average axial normal strain. Well, that would just be epsilon, which, boy, how do I want to solve that one? I could solve that because I'm gonna know delta over L, or I could look at I could also look at stress over Young's modulus, right? Either. Well, now it's just a calculator game, though. So if I do that, I start substituting in. My force is 30 kip. My area is pi. My outside dimension is 6 squared minus my inside dimension. Well, now this is a good question. If the wall thickness is 0.6, what's the inside? And many of you are going to jump right to 5.4. But there are two walls. Let me draw this for you because we do scuba tank problems at the end of this chapter. And this is the ID across here. I know you're going, wow, this, I got it. I know, but we still get it wrong. And that's because we just jump ahead. And this is the OD. So the ID plus two thicknesses is equal to the OD. So when my thickness, go back up to this problem, when my thickness is 0.6, I got to subtract two of those. My ID is 4.8 inches squared divided by 4, and that's in inches squared. And I can calculate that out. I'll do that in a second. For the second one, it's 30,000 kip times the length, which is, it's got a length of 24 inches. I'm going to go up. When I calculate area, I'm going to plug it in here. And then I'm going to put in an E of 29 MSI. And that's going to give me a number. All right. And then I'm probably going with this one. I'm probably going with delta over L. So I have to wait till I calculate this, and then I'll put it in. So you ready? Here we're gonna pause for the calculator. All right, let's jump back at it. Okay, so my area is 10.173. Kind of a lame one, but it's what we get. And that was evaluating. I'm in red now, so that was evaluating this. And then I plugged it in there. That gave me 2950 KSI. And then I wanted to wait a second to do this. I wanted to look at kips, which is pounds. And this MSI has pounds in the top, right? So the pounds cancels with the kips. Now I still have a K and an M, but that's okay. And then I have inches squared, and this is per square inch. So that square inch cancels with that. And so I'm left with units of inches. So I got that going for me. And when I do the math, because this mega is very large and this is only a kilo, I get 0.00244 inches. Should have gone with black, sorry. Or maybe blue, something a little less. And then I can come down here and I can just calculate. This is 102 micro. And that kind of makes sense because you got 244 divided by 24, right? That's delta over L. Delta over L. Delta over L is equal to 0.0244 divided by 24. So you knew it was going to look like a 1. Oh, I got my mug in the way on that one. There you go. All right. There's problem 5-3. Don't worry, there's more coming. Maybe this is going to keep going. Can't find the stop.